flying down to Arizona, and I'm thinking on my plane, how I was going to teach this next stuff to you guys. So you guys are part of my spring break, so thank you. That's just kind of fun. But I want to do a precursor, then lead into what the lesson is, just to make sure perhaps you have a pretty good understanding of this kind of stuff. So, so this is dealing with kind of a line chart. So let's say we have a function. Let's call it f of x, and let's say that we have this. Let's say we have this, polynomial of some sort. And if we had graphed this polynomial, let's say it looks something like this. And there's certain values that we know. Let's say that that's like -4. This value right here, let's call it at 2, and maybe let's call this one at 5. Okay? So there's times that we could look at a sign chart for the original. And what we do is we basically look at where it crosses the x-axis, and we have those listed. So what we'll do on this is we're going to call this one negative, this one positive, this one negative, and this one positive. Okay? And so if you are just given this on a sign chart, this would basically mean these numbers here would be where is it above and below the x-axis. Okay? So the positives and negatives refer to where the graph is above and below x-axis. I totally ran out of room, totally squeezed it in there. Okay, so does that kind of make sense? Can you see where it's negative, positive, where it would take place here? And so if we highlight it, we could look saying this region right here is this region here. This region right here is this region here. And then these regions here would be positive. And this region here would also be positive. And that's where all of that information is coming from.
Hello.
Good to see you. Okay, so that's the first thing I wanted to talk about. But the thing is, we can also have derivative sign charts that come with this. Okay, so a derivative sign chart, first off, you would see this, meaning that we're doing the first derivative. And the derivative sign chart might look something like this. It might go something like positive, negative, positive, negative. Okay? So if this is the derivative sign chart, this means basically our slopes. Okay? So if you were to say, hey, I had this on my thing, I know that I would get basically a positive slope, a negative slope, a positive slope, a negative slope. And so from there, you could maybe say, oh, I think I can give you an idea of what this equation might look like here. So this basically comes up something like this. So this could be kind of a very rough sketch of what the graph is doing. So the big difference between the two is if you have a sign chart of this is the original. This would deal with above and below the x-axis. If you have the derivative sign chart, that would mean your slope being positive or negative, and there are times that your slope could be 0. Okay, so that's what I wanted to start this stuff out with, if that makes sense. We good so far? So now they gave us this obscure looking picture where we have some letters. So this is letter G, letter F. This is on the 5.1 notes. This is E. We have D here. We have C here. We have B here. And we have A here. Okay, so this is increasing, decreasing. So things that I would know about this graph is, it appears that we have an arrow here. It appears it is decreasing from negative infinity all the way to B. And then it's also decreasing from point F to point G. Okay, that's where it'd be increasing or decreasing in this case. Okay, so it's decreasing here, and it's also decreasing here. Okay, and that's our original function, which is kind of a goofy looking thing. And as far as this increasing, it's increasing along here, and then it's increasing again up to this point. So it's increasing from B to D, and then from D to F, it's increasing. There's one obscure point here, which is point D. Point D is where our graph is constant. Okay, so in this case, our slope of our line is 0, so it's constant at D. Okay, so if I were to draw my F prime chart, if I were to draw my derivative prime chart from this, we have B, D, and F that we're listing. And so what it's doing is it's negative slope here, it's positive slope here, it repeats a positive slope, and then it goes negative. And because you have two of the same signs in a row, that means that you remember the bounce, wiggle, cross? That's where a wiggle's taking place for the most part. Okay, so this appears to be a wiggle on the bounce, wiggle, cross ideas. Okay, am I good so far? Do you feel comfortable with what I've stated? So again, the sign chart for the derivative gives you kind of an overall depiction of what the actual graph could look like, whether it's decreasing if it's a negative slope or increasing a positive slope. If I have two of the same signs in a row, that could take place. So if I did a really obscure example, let's say we had -5, -2, -1. Let's say we had 1, 2, and 3. Let's say it was negative to negative, positive to positive, negative to positive to negative. Okay? So that would mean at -5, we would have the slope of exactly 0. And at -1, we have a slope exactly of 0. So this type of graph, it's decreasing here, then increasing, then increasing, then decreasing, then increasing, then decreasing. And if you were to try and make a graph based off this, it would come down and at -5 kind of do this and then keep coming down till it got to 2. And then it starts, that's a -2, and then it starts increasing up until -1. And it does a flatten out, and then it starts increasing again till it gets to 1. And then it starts decreasing again till it gets to 2. And then it starts increasing again until it gets to 3. And then it starts decreasing again. So that's kind of what the graph would look like. I don't know what the relative maxes and mins are based on it, but that would be a visual interpretation of what a sine line graph could look like. So if we were to make our sine line based off of our A, B's, and C's that are listed from -2 to 4 at the bottom of 5.1 notes, we have this kind of graph where this is A, this is B, this is C. So if we were to make a sine line based on this, I'd have A, B, and C listed on here. So we'd have a positive slope here. I'd have a negative slope here. I have a positive slope here. And then it keeps going positive here. So because you have the positive and positive between point C, which in this case would be 4, that basically means that the graph has a point of inflection that takes place. So let's kind of make some ideas about what our graphs are doing. On an F prime chart, this point here is a point of inflection. And we don't really have to know this, but this basically means I had taken the second derivative and I set it equal to 0. Okay? A second derivative is done the exact same way a first derivative is done. You just do a derivative of the derivative to get to the second derivative. Okay. Are we all right so far? I kind of went fast on a Monday morning, and I apologize. And a Monday morning after break, you're like, dude, are you kidding me? I missed you too. I kept my head on the swivel when I was in Arizona going, I got to see butter. Yeah. Got to find butter.
Our Airbnb was all the way in Avondale. This is so nice.
Avondale, okay.
It's so nice to live.
Yeah.
And all the houses are all pretty.
Yeah, but I'll tell you what, that place becomes an oven here
Really?
in June, July, and August. Those are the 3 months that you don't want to spend time in Arizona.
Really? Where did GCU
It's
at?
GCU's on 35th Avenue in Camelback. It's in Phoenix.
It's in Phoenix.
Yeah.
It's like in Phoenix.
Yeah.
Oh.
Yeah. So it's on the west side of Phoenix. So the west side are the avenues, then you have Central's the divider, and then streets are on the east side of Phoenix.
So it's going towards the year?
Yes. Yeah, it's not too far.
Okay. I thought it was like northern. But...
Yeah, a lot of people, when I first went to Grand Canyon, you're like, oh, it's beautiful up there. It's like, it's East Phoenix. What?
Yeah. Oh,
all right, on the back side of that page, we have this given to us. And this is at 1, this is at 3, this is at 5. And so what we want to do is we want to try and sketch our graph based on this. So at 1, at 3, and at 5, we have a positive slope. And then it turns into a negative slope. And then it goes negative slope again. And then it comes up to a positive slope. So there's basically a rough estimate of what our graph might look like, and that's for example 1. And then example 2, they have negative, and that's at negative 3, and then positive, and then positive, and then negative. So if we wanted to make a rough graph of what this looks like, put your negative 3 there, your 1 there, and your 4, kind of space it out appropriately. So we'd have a negative slope till we got here, changes directions at negative 3. And oops, I made a mistake. So negative 3 here, negative here, and then it changes directions, flattens out for a moment, and then keeps going up until we get to 4, and then goes back down. So this would be negative slope, positive slope, negative slope. This is where some sort of point of inflection is taking place. We'll call it a POI for a point of inflection. Again, the point of inflection is where the second derivative is equal to 0. So now we're ready to play around with this graph, and I think we could do this graph pretty easily. So they want us to graph this equation. And yes, we could plug it into Desmos and it would do just fine for us. So the first thing I want to do is I want to go x to the third minus 12x equals to 0. And this is going to find me my roots. Okay, this is where it will cross the x-axis. Okay, so I'd factor an x out. I'd have x squared minus 12 equals 0. This x equals 0, so there's one root. And then I get x squared minus 12 equals 0. Add 12 to both sides. And then take the square root. Don't forget the plus minus. So a plus or minus root 12. And if you wanted to clean it up, yes, you'd certainly say 2 root 3. So if you were to take a look at this on a graph, you have negative 2 root 3, you have 0, and you have positive 2 root 3. Those are your roots, is where it's taking place. So that's basically where your graph is going above or below the x-axis at some situation. Okay, intervals where it's decreasing or increasing, well, let's find our first derivative of the given equation. So that's going to give me 3x squared minus 12. And this is now a parabola. So if we set this equal to 0 and try and solve this, so you get 3x squared, add 12 to both sides, divide by 3, square root of both sides. So x equals plus or minus 2. So 2 is like here, or negative 2 is here, positive 2 is here on this situation. So what is our graph doing? What would the maxes and mins take place? You could do a couple of things on here. Obviously, Desmos is available for you, so you could take a look at it. And we might as well utilize Desmos while we have it until they start making us pay for it. Get there, go Desmos. Graphing, and let's graph our original. So we have y equals x to the third minus 12x. Okay, so if you take a look at our graph, you had those particular values, but then I have a value up here. Actually, let's make this smaller. Let's define what all these values are. Okay, so the negative 3.46 and the positive 3.46 is got to be at 2 root 3. Okay, so if I went back here and I said I wanted to make sure that that's correct, what is 2 square root? Do it the other way. 2 square root 3. And what is negative 2 square root 3? And let's just make sure that those actually do exist here. So negative 3.46. So those values are where 2 root 3 and negative 2 root 3 exist. The 0 exists there. But if you remember, when I took the derivative and set it equal to 0, we got negative 2 and we got positive 2 that took place. Okay? So if I go back here and look at it, this plus or minus 2, the derivative is basically where a max or min take place. Relative max or relative min, not the absolute. Okay? So what you could do on this is, being that you know this negative 2 takes place and this positive 2 takes place, you kind of have to think what is taking place between those. And again, those are where it would peak. So it'd go from being a positive slope to a negative slope, or a negative slope to a positive slope, where the sign changes. Those are what things that take place. So what you can do is you take a look at it and say, okay, what if I were to take a number way this way, so say 10, and I plug 10 in here, I'd get 10 squared. 10 squared is 100. 3 times 100 is 300. 300 minus 12 is a positive number. And so you can usually come back and just label backwards like that, because you know you don't have any points of inflection. So is that truly where our graph is increasing or decreasing? And we can say yes. So we said it's increasing here, it's decreasing here, and it's increasing here. And those are all the fundamentals that are taking place on our graph. Okay? So then we can label it in interval notation. It's a positive slope so it's increasing from negative infinity all the way to -2, and then it's increasing again from 2 to infinity. And where is this decreasing? It's decreasing between the two, and that's what your graph is doing. So intervals increasing, decreasing. Do we have a max or a min? I would say for the max and min, I would definitely jump onto Desmos. So at -2, right up here, we have a max. So we have a max at 16, and we have a min at -16. So we have a max at +16. We have a minimum at -16. And I just gave you all kinds of good stuff about this stuff. All right, so let's take a look at, let's have you guys take a look at worksheet 5.1 and take a look at just 1 through 5, so the front only. And we'll go over that tomorrow. Okay? We good? We happy? And we got to figure out a real life math thing to do this week. I don't know what to do. I'll figure out something. That far